Could we really be alone in this vast universe? This question has intrigued us for centuries, sparking debates, inspiring exploration, and fueling our collective curiosity. The idea of extraterrestrial life has captured human imagination since the times of ancient Greek philosophers, who speculated about the nature of celestial bodies and the possibility of life beyond our planet. Our fascination with the cosmos has evolved into a systematic pursuit of knowledge with the development of telescopes, the scientific method, and our increasing understanding of the universe. Notable figures like Kepler, Galileo, and Newton have significantly contributed to shaping this understanding. In our quest to answer the enigmatic question of alien existence, we've developed tools like the Drake equation. Formulated by astrophysicist Frank Drake in 1961, this equation serves as a starting point to estimate the potential number of detectable civilizations in the Milky Way. It takes into account factors such as the number of stars, planets capable of sustaining life, and the development of intelligent life forms. The search for alien life is not a new endeavor, but a progression of human curiosity and scientific advancement. With each passing day, we inch closer to unveiling the mysteries of alien worlds, fueled by our innate desire to explore and understand the unknown. Our understanding of the cosmos has been shaped by notable figures like Kepler, Galileo, and Newton. Kepler, with his laws of planetary motion, laid the groundwork for our comprehension of how celestial bodies move in the vast expanse of space. Galileo, often called the father of observational astronomy, used his telescope to unveil a universe filled with wonders, from the craters of the moon to the moons of Jupiter. And Newton, with his universal law of gravitation, provided us with the mathematical tools to predict the motion of planets and stars. These early luminaries didn't just give us a way to navigate the stars, they also gave us the first inklings of the possibility of life beyond Earth. Galileo's discovery of Jupiter's moons, for instance, hinted at the existence of other worlds in our own solar system, and Newton's law of universal gravitation suggested that the same physical laws that govern our planet could apply to other planets as well, potentially making them suitable for life. These early theories have paved the way for the modern search for extraterrestrial life. They've inspired us to look beyond our own world, to question, to explore, and to dream of what we might find in the alien worlds that lie beyond our own. In 1960, the search for extraterrestrial intelligence, or SETI, officially began with Project Ozma. Named after a character in the Oz series by L. Frank Baum, Project Ozma was the first systematic attempt to detect radio signals from extraterrestrial civilizations. The project focused its efforts on two nearby sun-like stars, Tau Ceti and Epsilon Eridani, using a radio telescope at the Green Bank Observatory in West Virginia. Despite its short duration and limited scope, Project Ozma ignited the spark that would inspire future generations of scientists to continue the search for alien life. However, funding for SETI has always been a challenge. The search for extraterrestrial intelligence is a long-term project, requiring significant resources and commitment. It's a quest that can't be measured in months or years, but in decades. Despite these challenges, the search has continued, propelled by private initiatives that have taken the lead in this cosmic quest. Breakthrough Listen, for instance, is a 10-year initiative funded by the Breakthrough Initiatives program, launched in 2015 to search for extraterrestrial electronic signals. It's the largest ever scientific research program aimed at finding evidence of civilizations beyond Earth. Then there's Breakthrough Starshot, an ambitious multi-decade initiative that aims to develop a proof-of-concept fleet of light-sail spacecraft capable of making the journey to the Alpha Centauri star system. It's a bold vision that, if successful, could revolutionize our understanding of the universe and our place in it. While the search for extraterrestrial intelligence continues, so too does the debate about the risks and benefits of actively seeking contact with potential alien civilizations. Some scientists argue that we should be cautious, warning of the potential dangers of announcing our existence to the cosmos. Others, however, are more optimistic, seeing the search for extraterrestrial intelligence as a noble endeavor that could ultimately unite humanity in a common cause. While the search continues, the debate about the risks and benefits of actively seeking contact with potential alien civilizations persists. Our exploration of alien worlds such as Mars has provided valuable insights into the possibility of extraterrestrial life. Yet our cosmic backyard, the solar system, holds intriguing possibilities of its own. Icy moons like Europa, Enceladus, and Titan, orbiting the gas giants Jupiter and Saturn, are a focal point of interest. These celestial bodies, with their potential for supporting life due to water, chemistry, and energy, have become the targets of upcoming missions by the European Space Agency and NASA. In the frigid landscapes of Norway's Svalbard archipelago, scientists are studying microbes living in icy landforms called pingos. This research is not just a quest for understanding life's resilience on Earth, but also a potential blueprint for how alien life might survive on these icy moons. The findings could help us understand the kind of life forms we might encounter on alien worlds. But how do we get there? The answer lies with the ambitious missions led by global space agencies. These missions aim to explore the oceans and surfaces of these icy moons in search of signs of life. The journey to these distant worlds is not a simple one. The cost of these missions runs into billions, but the potential rewards are priceless. The exploration doesn't stop at our solar system. The next generation of space observatories, including the James Webb Space Telescope and the planned Habitable Worlds Observatory, aim to search for signs of life on exoplanets. These missions are expected to revolutionize the search for extraterrestrial life by detecting gases indicative of biological processes on distant planets. These missions, costly as they may be, could shed light on the origins of life on Earth and beyond. As we continue to explore the universe, we are not just seeking to understand alien worlds, but also answering fundamental questions about our own existence. The search for extraterrestrial life is not just a scientific endeavor, but a journey of discovery that could redefine our place in the cosmos. The next generation of space observatories is set to revolutionize the search for extraterrestrial life. As we move forward in our quest to unveil alien worlds, we're preparing to deploy some of the most advanced instruments mankind has ever constructed. Take, for instance, the James Webb Space Telescope, a marvel of modern engineering. This telescope will peer into the deepest reaches of the cosmos, capturing light that has traveled billions of years to reach us. With its advanced capabilities, the James Webb Space Telescope will be able to analyze the atmospheres of distant exoplanets, possibly detecting gases that may indicate the presence of life. But the James Webb is just the beginning. On the drawing board is a cutting-edge project known as the Habitable Worlds Observatory, or HWO for short. This successor to the James Webb will boast a mirror measuring 6 meters across, allowing it to observe at optical and ultraviolet wavelengths. The HWO is part of an ambitious program known as NASA's New Great Observatories. This initiative also includes the Lynx X-ray Observatory and the Origins Far Infrared mission, all aimed at deepening our understanding of the universe and our place within it. The primary mission of the HWO is to search for signs of life on exoplanets. Using its state-of-the-art technology, the HWO will be able to detect gases that are indicative of biological processes occurring on distant planets. In other words, if there's life out there, the HWO might just be the instrument that finds it. The future of space exploration is looking brighter than ever, with these initiatives expected to launch in the late 2030s to early 2040s. We're standing on the precipice of a new era in the search for alien life, one that promises to bring us closer than ever to answering that age-old question, are we alone in the universe? These missions are expected to launch in the late 2030s to early 2040s, heralding a new era in the search for alien life. Let's keep our fingers crossed that in our lifetime we might just find the answer. From ancient philosophers to modern scientists, the search for extraterrestrial life has been a long-standing human endeavor. We've journeyed together through the history of this quest, exploring early theories, the inception of SETI, the exploration of alien worlds, and finally, our future in this ongoing search. Our journey began with the question of alien existence. We delved into the minds of ancient philosophers and the theories they proposed, setting the stage for centuries of astronomical exploration and discovery. We then stepped into the space age with SETI, an organized effort to detect intelligent alien life, a pursuit that, despite its challenges, continues to inspire and drive us forward. Our exploration took us to alien worlds, from the icy moons of our own solar system to the thousands of exoplanets discovered beyond. We've learned about the potential conditions that could support life and the extraordinary lengths scientists are going to in order to unravel these alien mysteries. We've also looked into the future, a future defined by incredible technological advancements. The next generation of space observatories like the James Webb Space Telescope and the planned Habitable Worlds Observatory will revolutionize our search, detecting gases indicative of biological processes on distant planets. The search for extraterrestrial life is a fascinating journey, filled with scientific discovery and technological innovation. It's a journey driven by our innate curiosity and the desire to answer one of our most profound questions. But this journey is far from over. Every day, researchers across the globe are working tirelessly, combining telescope observations, lab experiments, numerical models, and advanced instruments to further our understanding of the universe. In the grand scheme of things, our search is still at its infancy. There's an entire cosmos out there filled with mysteries and wonders waiting to be discovered. We've come a long way, but there's still so much more to explore, so many more questions to be answered. The question remains, are we alone in the universe? The search for extraterrestrial life continues, with each new discovery bringing us one step closer to potentially answering this profound question.